Welcome to solverfy.
For this problem, we are asked, in how many ways can a photographer at a wedding arrange 6 people in a row from a group of 10 people, where the bride and groom are among these 10 people? If A, the bride must be in the picture, B, both the bride and groom must be in the picture, or C, exactly one of the bride and groom is in the picture. So, for part A, I'd say that we want to think about this essentially as 2 tasks. Task 1 is picking who's in the picture, and task 2 is arranging. Now, since we have task 1 and task 2, ultimately we can apply the multiplication rule, the product rule, and say that the total number of ways will be the number of ways for task 1 multiplied by the number of ways for task 2, but we don't know what those will be just yet. So for task 1, we would initially think, okay, we have 10 people, and we need to choose 6. But we were told that the bride and groom are counted amongst those 10. So, in part A, we know that we are including the bride. So we're not choosing we're not choosing 6 people. One of them is already chosen for us. We're only choosing 5 people. So, we can think about it as we have 1 slot already dedicated to the bride, and then we have 5 remaining slots we need to fill. And we would have 9 ways to fill the first slot, 8 to fill the second, 7 to fill the third, 6 to fill the fourth, and 5 to fill the fifth. So we'll have 9 times 8 times 7 times 6 times 5 different ways of choosing who out of the original group of 10 we'll be seating. Thing is that in this step, at least, the arrangement doesn't matter. It doesn't matter which order we're choosing people. Currently we're just saying, okay, everybody, you, and you're all coming over here for the picture. Doesn't matter what order we say that in. So, the number of actual ways here is going to be 9. So actually, I'll say ahead of time. What we know then is that we're going to have multiple different ways of arriving at the same group for the picture. So, we know that we'd have 9 times 8 times 7 times 6 times 5 different ways of choosing who will be included. And then we need to divide out the number of different ways that this group, this sort of pre-group, we could call it, we need to divide out the number of ways that this pre-group could be arranged. So we would have 5 ways of choosing the first person, and 4 ways of choosing the second person, and 3 ways of choosing the third person, 2 ways of choosing the fourth person, and 1 way of choosing the fifth person. So, the number for our first task is going to be 126. For the second task, we are arranging our group of 6. So, for this, we have, we're arranging them in a row, and we're not told at all about who needs to sit where. So we'd have 6 ways of choosing the first person, 5 ways of choosing the second person, 4 ways of choosing the third person, 3 ways of choosing the fourth person, 2 ways of choosing the fifth person, and 1 way of choosing the sixth person out of the group that we arranged for the first task. So we're multiplying all of that together. 6 factorial is going to be 720. So the total is going to be 126 times 720 which will give us 90,720. For part B, we'll have a similar process, but we have that both the bride and the groom must be in the picture. So, for the first task of choosing who will be included, we have our initial set that we're choosing out of reduced to 8 choices we need to make. So we need to choose 8 people to fill 4 slots. So we'd have 8 times 7 times 6 times 5. And then we need to eliminate the different ways of repeatedly, or of eliminate the different equivalent ways of arranging those. Because like I said, for the first task, this is where the order isn't going to matter, or shouldn't matter. So we'll divide by 4 times 3 times 2 times 1. So the result that we get here is going to be 8 times 7 times 6 times 5 divided by 4 times 3 times 2 times 1. So that's going to be 70. And then for our second task, we'll have, similar to before, the arranging step. Well, we know that the bride and the groom have to be included in this, but we don't have anything, we're not told anything about where the bride and groom have to be. So the arranging step is actually going to be the exact same. We'll have 720 ways of arranging our new group. So we'll have 70 times 720 different ways. So total 70 times 720, which is going to be equal to 50,400 ways. For part C, we know that exactly one of the bride and the groom is in the picture. So for our task 1, deciding who's going to be included, as we were told, exactly one of the bride or the groom will be included. So essentially, our first thing we need to decide is it going to be the bride or the groom included? So 1 second here. Okay, so we have 2 times 8 times 7 times 6 times 5. 1, 2, 3, 4, 5. Then times 4. And we need to divide to make sure that we don't overcount the repeated different ways of getting essentially the same group, preliminary group we could call them. So we'd have to divide by 5 times 4 times 3 times 2 times 1. One moment here. Okay. So the result in that case would be 112. And the arrangement step, the number for our task 2, is going to be the exact same thing as before. So we'd have 720 different ways of arranging our 6 choices. So the total is going to be 112 times 720, which equals 80,640 different ways.